Well, welcome back. We are in what I believe to be the final leg of the IC&D1 Review Lab, rebuilding the structure. Some key concepts to finish this up, like NAT, getting internet access working. I mean, pretty key for our organization. Before we dive right in, can I just convey to you one more time how much I love Cisco? I know, you're like, okay, I got it, you're a Cisco nut, but no, before I was Cisco, I was Microsoft, before I was Microsoft, I was Novell, so I've gone through a lot of technology, and I was just reminded again, so here's what happened, right? Windows Update popped up, bing, just like this, and they're like, oh look, some updates are available. I'm like, okay, well let's see what's here. Ooh, a new driver update. So, okay, long story short, I checked those two boxes right there, because not Bing Desktop, why would you do that? But then these two, I'm like, okay, well, let's get up to date, get my drivers going, all that. And so, bam, an hour of my life is gone. Why? Because I install those, my computer reboots, it's in 640 by 480 resolution, like it's like giant everything. I'm like, so I look, and the driver update failed. I try and reinstall. It's like, oh, sorry, Windows update failed. Error code XJ5960XAAB9. I mean, just stupid stuff. So I'm sitting here like, okay, so maybe I got to manually download this driver. I'm looking around, and Intel, go to Intel. They're like, well, actually, we don't have the driver for your operating system because it should be installed by Windows Update. I'm like, I don't know. So I'm sitting here screaming at it, and finally I'm like, oh, wait. Windows has this great feature called System Restore, right? So I launched System Restore, and I restore it back to like 2 weeks ago, and bam, here I am back in action an hour later. I know it didn't seem like an hour work, but that was the most unsatisfying resolution to something. I'm like, I have no idea what's wrong. The driver won't install. Windows Update is like error code XJ59B. I don't even know what, I'm like, oh wait, here's a blow up everything button. Let's go back to 2 weeks ago. Thankfully I didn't install anything in the last 2 weeks that I really needed or anything. But that's what fixed it. And I'm like, man, as I get into this, Cisco is just so logical. I was just, I was up last night, talking to my brother, who was actually at, a client site working remotely, and he's like, dude, bail me out, I don't know how. He was setting up a Metro Ethernet connection for a customer. So I'm walking him through how to get the VLAN tags going across, and he is just like, oh, this is great, I get, like, everything worked like it was supposed to. No error code XJ59B. Let's get back in the lab. So, we left off in the last nugget, getting the PCs to communicate between the VLAN. I mean, a lot of great stuff. But now we need internet access. So let me just read these objectives because I want to make sure we're all on the same page. Configure NAT on router 1. Who's router 1? That guy. Router 1 in such a way that all users of the corporate office can access the internet by sharing the public IP address assigned to router 1. Note, only valid IP addresses from the corporate office should be permitted to use NAT. Okay, that's in there for a reason. Router 1 should NAT only IP subnets in the network diagram. Okay, it's almost like emphasized twice. Only these addresses. Okay, so I'm getting the feeling it's not lazy NAT. I'll explain that in a moment. Verify a NAT is working by pinging 4222 and 8888 from PCA or PCB. Okay, good. And then we go on into security. So let's focus in on the NAT first. We're going to start off on PCA just to make sure that it doesn't work. There's nothing more fun than reaching the end and you're like, oh, it works. Well, did it work before? So it's got an IP address. Let's just ping 4.2.2.2. And no, we are being denied. And again, we talked about this in the last nugget, but where's my pen? What's happening is PCA really is coming up here to router 1, its default gateway, and router 1 really is sending it out here to the ISP. The problem is there's no NAT involved at all, so what the packets are going through as 10.24. 2.100, so they're actually coming out here, and this guy out here is going, well, I have no idea who 10.24.2. anything is. Matter of fact, if this were a real ISP, he would have an access list on here, configured to block all those private addresses, because that's what ISPs do. So it's not going to be allowed to get out, and we're verifying just both of those addresses not working at all. Okay, so Second thing I wanted to mention, and this is for you GNS3 folks, GNS3 I found is not, well, at least for me, that this just happened to me a moment ago, is not saving my VLANs. It's saving all the VLAN config, like what ports are in what VLANs, but VLAN 2, VLAN 5, they disappear from switch 1, 2, and 3. I'm sure there's just a save setting I'm not clicking, and I just don't want to spend the time to figure it out. But what I do is I just access switch 1, switch 2, and switch 3, and add those VLANs manually back in. And we saw that again in an earlier nugget, but I just want to bring it up again in case any of you are pulling your hair out like, why isn't nothing working? So add the VLANs. Okay. Now let's go to router 1. GNS3, router 1, bing, there we go. All right. So router 1 is going to be our NAT router. Now looking back at the objectives, it was saying that, well, let me bring this guy back up. It was saying configure NAT in such a way that everybody can access the internet. Note, only valid IP addresses from the offices should be only IP. Okay, so when you configure NAT, remember, you have to go in and specify what addresses are allowed to be translated. And the notes in the lab explicitly said only addresses from the office, almost twice in 2 ways. So what I would do is I would take that and I would say, okay, if this were a Cisco exam, I would say Cisco's after me. I'm not going to be able to create a standard access list that just says, yeah, NAT everything, or NAT just everything that starts with the number 10. I would go in just based on what was being said there, and I would, let me move this up here. I would actually create NAT specifically on the subnets that I see in this picture. So I'm going to create an IP access list. It'll be a standard access list, and we'll just say NAT addresses. It is case sensitive, so you have to remember capitals if you use them. And let's do the corporate offices. Permit 10.24.0.0 wildcard mask 255. I'm going to add in, let's throw the branch next just because I've got that same subnet mask. 23, 24, 23, and then that WAN link. We'll NAT that in case something pings from, it said every subnet in the corporate office, and that is one, so I'll do permit 10.15.1.12 is the subnet. Okay, /30. Now, if we're trying to figure out that wildcard mask, what I would do is take 255.255, all 255s, and subtract the subnet mask, 255.255.255.252. Subtract that, and I would say, okay, that is 0.0.0. and then 255 here minus 252 ends up being 3. So the wildcard mask that matches that subnet specifically is 0.0.0.3. It's a weird one, but that works. Okay, so I've got those specific. Ooh, good grief, Jeremy! I totally forgot about the accounting VLAN and the IT team as well, which is going to be our test cases. So that's not going to work. So 24.5 is accounting, and 24.2 is the IT team VLAN. Okay, let's go do a show IP access list. There's our NAT addresses. I'm feeling good about that. Okay, now second piece of NAT is I have to tell the router which interfaces are inside of the network and which interfaces are outside. So let me make this just a little bigger so I don't get that word wrap. Show IP interface brief. Okay, so there we go. We got fast Ethernet 00, inside. Now you got to mark all of those as inside interfaces, not just this one, but also the sub interfaces. And then this guy is the outside interface. So how do we do that? Fast Ethernet 00 IP NAT inside 00.2 IP NAT inside. They created a little virtual interface for us that does the NAT magic. 5 IP NAT inside. Good. Now interface serial 0/0, and that one I'll say is IP NAT outside. So where are you coming from is what it wants to know, and where are you going to? Okay, good. So now let's go look back at the lab, because I think there will be an easy way and a more difficult way, not impossible, but more difficult to do it. It says configure NAT in such a way that all users can access the internet by sharing the public IP address assigned to router 1. Okay, so I'm going to show you the easy way first, and then I'll show you how to do it, well, no, the hard way. So let's go here. I'm going to say the command that combines them all together. So I'm going to type this command, right? And then I'll come back and explain it. So I'll do IP NAT inside source list NAT addresses, right? NAT addresses. So NAT addresses, and I'm going to the interface serial 0/0 and overload that guy. Good. So now let me explain it. So this command puts it all together. Think of this as the glue that binds all of the NAT configuration together. So this says IP NAT. Let me be an English translator here. I want a NAT. So the router says, well, where do you want a NAT from? I say, I want a NAT from the inside of my network out. And the router says, okay, well, great. Tell me what the inside of your network is. I said, well, actually, the source addresses that are on the inside of my network are defined in the access list NAT addresses. That's what we defined before up here, which says all of these and only these, based on the lab objectives, are allowed to be translated. So I'm saying those are my inside addresses, and so the router says, okay, where do you want to send them? And I say, well, actually, I'm going to send them outside. The outside interface is serial 0/0. And by the way, overload that interface. What's that mean? Well, it means share that IP address for all of these using a technology known as port address translation, or PAT. Use ports to make all of this unique. We cover all that in ICND1, right? So this just says take these inside addresses, send them out this interface. Now, the reason I love this command, this syntax, is because whatever the interface IP address is of serial 0, that is what it becomes with NAT, which is really handy because a lot of you and a lot of me are sitting at a house where you get your IP address from the ISP using DHCP. As a matter of fact, most ISPs will charge you money if you want a static address, and we know we don't want to pay money, but if we actually typed what IP address we want to translate them to, 188.23.163.173, if we type that IP address in there and then it changed, well, NAT will break until we come back and fix it with the new address. Well, this says don't even type an address in there. Whatever address, could be dynamic, could be static, is assigned to the outside interface is okay. So that's the easy way. What's the hard way? And Jeremy, why would I use the hard way? Well, the hard way is creating what's called a NAT pool. So I could say, I want to create a pool of addresses. Now, in this case, it would only be one because I only have one address assigned to me. But you can, in the real world, you could do more. And I'll say these are the addresses I want to NAT to. Now, the advantage and why you might want to go the hard way. Let me show you the command, what it looks like. So let me remove this guy. That was the easy way. So here's what I would do if I was doing it the hard way. IP NAT pool. I would actually create a pool. Now I'd call this outside IP. And I would say the start IP address is 188.23.163.173. The end address, actually, it's going to be exactly the same thing, so I'll just type that in. And it's going to ask for what is the net mask, and I'll say net mask is a 255.255.255.248. That's the /29, right? So this essentially says I have a pool, an outside IP pool of one IP address. .173. Now, same command as before, IP NAT, I want a NAT from the inside of my network out. The source addresses are going to be defined in the access list NAT addresses, right? But now, instead of saying I'm going out this interface, right, I'm going to say I'm going to go to the pool. I'm going to say the pool of addresses that I want to go to is going to be, what was it, outside IP, right? This NAT pool that I defined up here, and I want to overload that. Okay, so that's the how you do it. Now come back to the question I asked. Why do I do that? Why can't I just use the easy way? Well, in the larger organizations, as you go from 10 to 20 to 100 to 1,000 computers running on your network, which is not rare anymore, a lot of larger organizations have that, you start reaching the limits of an IP address via PAT. Like, you run out of ports. There's only 65,000 ports, which I know you're like, only? That's a ton. But remember, every single time, I don't know if I've shown this to you. If I were to open, we've got my little Google Chrome here, and I'm going to open command prompt, and I'm going to go in here and just go to one website, msn.com. Bam! Angelina Jolie. Oh, that's terrible. I don't want to know that. So, I'm going to, like, I see this one website, I come back here, and I do netstat. And look at this. I've got, well, these are all kind of internal connections right here, but starting right here and working its way down, these are all individual connections that it's making to outside IP addresses. Now, so this one MSN.com, sure, there's MSN HTTP, but it's loading up pictures. I've talked about this before. This one website could be 50 different servers that are feeding images, feeding ads, feeding all this kind of stuff. So your one website that you search with your one computer could eat up 50 or 100 port numbers temporarily in that. Well, you combine that with 1,000 ports, and what do you end up with? You end up with an IP address that is maxed out, and it starts eliminating ports too soon, and people's connection starts dropping, all that kind of stuff. Not good. So what you can do is create a pool with multiple public addresses. I only used one for this outside IP pool, right? You get it? And so as I max out one IP addresses, it moves on to the next, and moves on to the next, and moves on to the next, to where I have all those. So that's why the hard way may be the right way for a larger organization. For smaller, throw it at the interface. That's all you need to do. Okay. So the lab didn't specify easy way or hard way, so I'm just going to leave it as it stands. Now I want to test it. I want to go back to that PCA and get logged in there, and let's do that ping to 4222. Oh, so delicious. 8.8. Oh, not that one. 8.8.8.8. I actually wrote a blog post on why 4.2.2.2 will always beat 8.8.8.8, and it's just the fact that I can easily type, not using the numeric keypad, but easily type it with two hands and go so much faster. Anyway, so let's come back here. Router 1, I'm going to do a show IP NAT translations and hit enter. Oh, look at that. We've got two, notice ICMP, that's our ping protocol, our echoes, coming from our inside IP address. Who's that? Well, let's find out. Show IP interface brief, that should be our PCA. Same IP address right there. Good. Okay, so then we're saying, okay, inside local, that's the inside private IP addresses. It's going to the inside global. Inside meaning it's under your control. Global meaning it's a public address of this. So this is what it's being translated to. That's our outside IP address on our router. That's our outside pool. Where's it going? It's going to these guys. And you can see the little ICMP. I'll call it a port number, but ICMP doesn't quite use ports, but we'll call it that. So we've got these guys, which we're actually paying. Now I hit the up arrow. Notice they're disappearing. This first one timed out because it only stays in the NAT table so long. I'm sure. Oh, there we go. I hit the up arrow again, and it's gone. So that fast, they were there, they were gone, and NAT is working. So just to double confirm, I'm going to go to PCB, minimize that guy. Show IP interface brief. Make sure it works from the accounting VLAN ping 4.2.2.2. Oh, I was like, that's not good. Okay, so PCB, it is working. We just had to get that initial lag of resolving an ARP message, but now everything's good. If I come back here, do that show IP NAT translations. Come on, we got to build a little more, right? Get a couple people in there, and we are doing NAT. So NAT is working. We're able to ping the outside world. I'm good with that. Okay, now let's move on to our next objective, if I can get my screens in order here. Implement security on router 1 in such a way that internal users are only able to access the internet using HTTP and HTTPS. Okay, so we only want our users web surfing. Okay, so there's a couple ways we could approach this, I would say an easy way and the hard way. So first off, HTTP and HTTPS. We've got TCP port 80 for HTTP, and HTTPS is TCP port 443. Just got to memorize some of those TCP port numbers. So the easy way, I would say, would be to apply it outbound, meaning as a user goes out this direction, that's where the filter comes in. Because if we do it inbound, we have to say, okay, only allow HTTP and HTTPS, using those permit statements. But then we've got the implicit deny at the bottom, right? Which means that if it's not this, then nothing else will be able to reach router 1. Again, if we apply it inbound right here, which means OSPF communication would fail. Right? Because OSPF would be trying to communicate, sending hello messages. It's like, oh, sorry, you're not these guys. You see the pain that would be involved there. So it's doable to apply it inbound right here. But I would say let's go the easy route and go with an outbound access list. So as things are going out this way, we're only going to allow these kinds of communications. Okay. So I'm going to come over to router 1 and hit global config mode. So let's do an extended access list. So I'll be IP access list extended, and we'll do internet smackdown. Smackdown. We're only allowing web surfing, so I'll say internet blessing. So permit. So we're going to say the TCP protocol because that's what HTTP and HTTPS ride on. TCP from any source host. Now I could say from this public IP address here. Oops. This public IP address, there we go, that I have right here, 188.23.163.173 as the source, but you know what, if I'm applying it right here, there shouldn't be any other sources, anyway. So we'll say any source going to any destination, And this is where a lot of people get tripped up because they immediately go for a port number here. And if you apply a port number between the source and destination, that means it's a source port number, which we're not filtering on source ports. We're filtering on destination port 80 and destination port 443. So we say any source to any destination using the destination port equal to 80 and 443. So I'll put equal to, and I never use this list at all. I just type in 80, hit the up arrow, 443. So let's do a show IP access list. And we've got Internet Smackdown, www, and 443. Doesn't have a keyword for that, but that's okay. So I'm going to exit back out of the access list mode. And let's go into interface serial 0/0. Oh, although this could interfere with the little ping testing, right? So let's apply it. So I'm going to say IP access group. I'm going to apply this to the outside interface. So it says, okay, what access list do you want to apply? I'm going to say it's going to be the Internet Smackdown. And the direction I want to apply it, so important on this, I'm going to say it's as things go out this interface. So outbound from serial 0/0, be the router. Pretend that you are the router and things are leaving your arm when you're thinking about directions on this. Otherwise, it gets very confusing. So we've got IP access group, Internet Smackdown in the outbound direction. Okay, so now, let's see to test. Well, here's the problem that we're going to run into. Now I'm going to go to our PCA and PCB, right? So there's our PCA, and I'm going to ping 4.2.2.2. Denied. And you can tell it's being denied by an access list because we're getting these ICMP unreachable. That's the use. So that means something is blocking you. It's not just request timed out. It's unreachable. So we're no longer able to ping. Now, okay, Matt, I'm going to modify this. I'm going to change this lab to say, you're going to see it when you download your guide. This should not impact the ping testing that we're using right here, because obviously we undo this objective if we apply the next one because we can no longer ping those. So let's go in here. Let's modify that access list. I'll do IP access list, set it Internet Smackdown, and we'll squeeze in a line at the end. We'll do a permit. Instead of TCP or UDP, I'm going to say ICMP from any source to any destination. Now we can actually get in and say just echo packets, but I'm not gonna get to that level. I'm just going to say permit all ICMP. And now we're looking good. Now we can come back here and do a show access list. And now I'm seeing the ping is matching. Let's do another test. Let's do a telnet to 4.2.2.2, which is our outside on port 80, which will allow us to test. Well, I mean, if I leave the port number, it's going to do port 23, and it's like bam, denied immediately. But if I put 80 and I go in there, oh, looks like we're open. So that means something connected on port 80. If I come back here and hit the up arrow, I'm seeing, looks like we got some matches on the www port. Now there's nothing that I can do. What would be the message? Get? Is that? Yep, there we go. So that's what, by the way, that's what your web browser does behind the scenes. Although not quite in the format that I did, because it's like wrong. So this verifies that it's open. Now that's just because our router that is simulating the internet right here responds on port 80. I don't think it responds on port 443. But let's try, yeah, so connection refused, but if I hit the up arrow and check it, okay, so we are seeing that we're at least getting a match. It's trying to get out. It's just the remote router up there doesn't support HTTPS connections. Good. Okay, so I'm going to have to remember to change the lab objectives to allow the pings, but that does it. That allows only those ports from our internal users to be able to connect on the outside. All right, last objective. Prevent users outside the 10 network, 10.0.0/8, from managing via Telnet or SSH any device inside your corporate network. Okay? Then test your configuration from router 1 using a source interface of serial 0/0. Okay, so all of these devices are Cisco devices. Anybody can telnet to them or SSH. They're just, the requirements are now saying, we only want to allow people whose address begins with the number 10. So these guys, to be able to telnet manage, and the way that we can test that is to actually try and telnet from router 1's source interface of serial 0/0, which is not in the 10 network, and just make sure that that is denied. So let's bring this up. Well, actually, I've got router 1 sitting right in front of me, so let's go there. So this one shouldn't be too bad. It's just knowing where to apply it. So let's do an IP access list. I'm going to do a standard access list, because it'll be simpler that way, and I'll just say VTY access will be the name. Can you see why I love named access lists? Why use the numbers when you get good names? So I'm just going to say permit. The one statement will be permit. Matter of fact, let's do this. We'll get a little notepad action going. Permit 10.000.255.255.255 enter. Good. That's it. Because it should just be the 10 network, right? And so I'm going to get these into Notepad, just so that when we get to, because it's at every device, so we're going to just kind of plaster these in all the rest of the devices. So permit that, exit back out of that, and we'll do line, so now I'm just in Notepad, line VTY 0 space 4, which will put us into the line configuration mode. And we're going to do access class. It's not IP access class, it's actually just access classed. Followed by VTY access. We're applying this VTY access to the telnet ports. Now, could you do this by applying an access list inbound on F0 and inbound on serial 0, for example, on router 2? Yes, you could, but it's just a lot more work for something done very easily by applying this to the VTY lines. And we want to make sure we're doing it inbound. Otherwise, you're filtering connections going out from your device. So, VTY access in. Get that bad boy in Notepad. And now, simple enough, let's just do copy, and we just hop over to, let's go to switch 1. It's at all the different devices. So config T, move it down here, paste. See how easy that is? Control Z, right mem. So switch 2, I get the idea, right? So let me pause the nugget. I'll just plaster this in, and we'll come back to test. All right, that is now done. So to test, I'm going to try and telnet first off from router 1 internally. So let's get rid of all this internally, and make sure that I still can telnet from the 10 network. So from the 10 network. So I'll go to 10.15.1.13. Let's just hit the serial 0 interface of router 2. Good. Good. So we're sitting on router 2. Exit out. Just one more telnet. Let's go to 10.24.0.11, which is switch 1. Wait a second. That's not good. 10 dot. Oh, good. It is there. Nugget love. So there. I'm on switch 1. Okay, so exit out of that. And so we're good. Okay, so now I'm going to try and telnet. Let's hit the up arrow and just do that same telnet command to router 2. But this time I'm going to use the source interface. So let's use /source interface of serial 0/0, right? Which is something outside of the 10 network. Right. That wasn't supposed to happen right there. So okay, let's troubleshoot. Let me bring up where are we? Router 2. Router 2. So let's get in. I get love, and let's find out why we're still accepting telnet connection. So let's do a show run section line VTY. Oh, did I just not apply it here? I think hang on, show access list. Oh, well that explains it. I just missed router 2 in applying. Well, see, I guess now you can see that it does work from serial 0/0 until. Let's get it. Oh, I replaced my clipboard, so I'll do copy, global config, paste. There we go. Okay, so exit, and now let's bail out of here. And hit the up arrow and try it again from that same source interface. There we go. Okay, good. So connection immediately refused. There's no time to even hang there or anything like that. So show access list, we've got VTY is allowed, but I still am able to telnet from the inside interface, right? So I'm able, and now you can see I'm getting 2 matches on that. So the implicit deny at the bottom of that, as long as you apply it to the device, will definitely take effect and restrict that. Good. So that I need some theme music or something, is rebuilding the structure of the ICND1 review lab. At this point, if you just went through and watched me do that, as in you did not try the lab yourself, I would seriously encourage you to set aside an hour. I would say, I would say an hour of time to go through and do this lab yourself. I mean, 3,281 Bitcoins on the line, right? Take that time, set it aside, and just go through this lab and get your fingers going. Because again, watching somebody do it is valuable, but nowhere near as valuable as actually trying it yourself and making your brain think, getting out of kind of the watch mode, and actually conquering this on your own. Once you've done that, then jump into the ICND2 series. You are ready to go. I hope this has been informative for you, and I'd like to thank you for viewing.